This is Brendan with Cusack Prep, and in this video, we're going to be describing how you divide or rationalize complex numbers when you encounter them. As far as rationalizing complex numbers, there are basically two different types of complex numbers that you would have to rationalize on any major standardized test. The first is relatively simple, and that's where you just have I or a number multiplied by I in the denominator. So for example, maybe we have something like 3 over I. Well, the rule with complex numbers, just like the rule with radicals that you might remember, is that you don't want to leave I in the denominator, just like you don't want to leave a radical in the denominator. With radicals, because a lot of you might be a little bit more familiar with those, if you had something like 3 over root 2, you would rationalize this by multiplying both the top and the bottom of the fraction by root 2. So the top would become 3 times root 2, and the bottom would become root 2 times root 2, which is the square root of 4, which is just 2. We're going to do something very similar with complex numbers, in that we're just going to multiply by I over I in this case. So if I multiply 3 over I times I over I, I'm going to end up with 3I divided by I squared. Now, if you recall, I squared is just equal to negative 1. I'm going to go ahead and just rewrite this pattern out up here. So what we can do is just take that bottom number and turn this into 3I over negative 1, which is just equal to negative 3I. And that's how we would do a problem like that. If there's only I, or a number multiplied by I, in the denominator, we simply multiply the top and the bottom by I over I, just like what we would do with radicals. Another example might be if we have something like 5 over 3I. Again, we have a single term in the denominator, so we're going to multiply both in the top and the bottom here by I, and we're going to end up with 5I over 3I squared. Recall that I squared is just equal to negative 1, so this is 5I over 3 times negative 1, 5I over negative 3, or just negative 5I over 3. I think it's probably good. I think it kind of gets the idea across. This tends not to be too difficult of a concept for most students. What is a little bit more complicated, though, is when you happen to have two values in the denominator, two separate terms. So that might look something like this, 3 over 2 minus I. Now, what do we do when we have a problem like this? So we have to get I out of the bottom. So if you just multiply the top and the bottom by I, that's not going to work here. What you have to do is multiply the top and the bottom by what's called the complex conjugate. So over here, I'm going to explain what that is. Conjugate. Oops. Okay. So what the complex conjugate is you simply change the sign in between the number. So for example, let's say we had 2 plus 5I. Well, our complex conjugate of that is just going to be 2 minus 5I. We're simply switching the sign. That's the only thing that's changing here, is the sign that's in the middle. Now, let's say we had another example where we had 3 minus 4I, and we wanted to figure out what the complex conjugate is of that. We would do 3 plus 4I. We're just switching the sign in the middle. So let's say we wanted to rationalize this. What we do is we multiply both the top and the bottom by the complex conjugate. So we're going to multiply this by 3 plus, wrong problem. We're going to multiply this by 2 plus I over 2 plus I, because 2 plus I is the complex conjugate of 2 minus I. When we do that across the top, we're simply going to distribute. So 3 times 2 is 6. 3 times I is plus 3I. And on the bottom, we're going to FOIL this out. 2 times 2 is 4. 2 times I is plus 2i. Negative I times 2 is negative 2i. And negative I times negative I is minus I squared. And the reason we multiply by the complex conjugate is it just so happens that our plus 2i and our minus 2i will always cancel out, or whatever the 2i terms that we produce are. So what we're going to have is 6 plus 3i over 4 minus I squared. But if you remember, I squared is just negative 1. So this ends up being 6 plus 3i over 4 minus negative 1, which just gives us 6 plus 3i over 5. So we can see how that by multiplying by the complex conjugate, we were able to get rid of I in the denominator. It's a crafty little trick. Now, if we wanted to put this in standard form, we could just separate out the 6 over the 5 and the 3 over 5i. And this would be standard form. This is probably what the answer choice would be on the SAT or the ACT. Let's just go ahead and do one more example. Go ahead and write another one right here. And in this one, we're going to have I in the top and in the bottom. Remember, our goal is only to get I out of the bottom. So let's say we had this problem right here. What we want to do is the same thing we did last time, where we want to multiply both the top and the bottom by the complex conjugate. The complex conjugate of 4 minus 3i is 4 plus 3i. So what we're going to do is we're going to FOIL it across the top, and we're going to FOIL it across the bottom. When we FOIL across the top, 3 times 4 is 12, plus 9i, plus 8i, plus 6i squared. When we FOIL it across the bottom, 4 times 4 is 16. 4 times 3i is plus 12i, minus 12i, and then minus 9i squared. So in the top, we're going to end up with 12. The 6i squared, remember I squared is just negative 1. So this is going to be 6. 9i plus 8i is 17i in the top. In the bottom, the 16 minus 9i squared, 16 minus 9 times negative 1 is going to give us 25. And again, this plus 12i and this minus 12i are going to cancel out with each other. And so we end up with this final form. And if we want to put it in standard form, once again, we would just split it. We would turn this into 6 over 25 plus 17 over 25i. And that's how you deal with complex numbers, dividing them as well as rationalizing them. So we went through a few different examples here. May post another video with some additional examples at some point, as this can be a little bit more challenging of a topic. But the key things to remember are, again, this whole pattern of I to the first equals I squared equals negative 1, I cubed equals negative I to the fourth equals I, or 1, as well as how to figure out what the complex conjugate is. Remember, if you only have one term in the denominator that has I, you multiply by I over I. Whereas if you have two terms in the denominator, that one that has I and one that does not, you want to multiply by the conjugate. And that's basically it. Thank you for watching.